It's in the middle. It's in.
Oh.
That's why.
And does it run like southwest and north?
It's the valley roughly is like east west, east south.
Okay, welcome to our, woo, that's loud, huh? Yeah. Let me say a little bit about myself. No, welcome to our weather discussion for today. Boring weather around us, but there's never really such a thing as boring weather. There's always interesting weather. And there's going to be a couple things I'll talk about that are interesting throughout the conversation, and then Professor Morgan will say more about the tropics, which are finally in the Atlantic Basin pretty active. So here's the week-long satellite movie over the tropics, and you can see there's Gabrielle falling apart as it makes quote landfall with the Azores, and it's going to head towards actually north of the mouth of the Mediterranean. And where are we in the week, Pete? Is that Gabrielle?
I do not know.
Yeah.
Okay, that's Gabrielle.
No, that's Humberto.
Let me get my bearings.
September
That's Gabrielle, yeah,
22nd.
okay, it started again.
Okay, so that's Hurricane Gabrielle, which at one point was a Category 4 storm, I believe, right? And it exploded to that intensity over a short period of time. So that was the first really interesting, I think probably safe to say, the first really interesting event in the Atlantic Basin this year in terms of rapid development. And then we had, we're going to see later on as the movie goes on, the development of now Hurricane Humberto, which is got 90 knot winds, so it's a Category 2 storm or maybe Category 1 storm. And then there is yet to be named late in the week, so as you get to the end of the bar, you'll see the development over the Bahamas and north of Cuba. That's, or maybe it's over the Dominican Republic and Haiti. I guess I had the wrong place. Yeah, this is where Imelda is going to come from, and that's Humberto, which currently has 90-ish knot winds.
No, the loop started again.
Damn it. It's too long. It's just too long. So I'm sorry I'm pointing out the wrong things. You probably know. It'd be great if we stop it a couple of times. So there's Gabrielle. Forget about her. She's now not even a tropical cyclone. And then this must have been, let's keep going. I don't know where things came from. It's okay. We don't need to probably do that. But let's see what happens, where the next one comes from.
Right there, yeah.
Right here, this is Humberto,
Yeah.
and then this convective cluster south of, well, between Haiti, Dominican Republic, and Puerto Rico is what's going to become Imelda. Is that correct?
Yeah.
Okay. So this one's already a hurricane, and it's a Category 1 storm. Had a pretty decent, I think it had a better looking appearance yesterday than it does today. That's my opinion, but I don't know if that's what the Hurricane Center says. We'll hear more about it as we go. But Imelda is the first tropical disturbance in the Atlantic Basin that has a substantial risk of landfall in the United States. And yesterday, it looked like it was kind of on a dead-on track for Sunday afternoon, Sunday night, Monday for Charleston, South Carolina. So right about here. I don't know yet what the forecast is today. We'll leave that for later on in the discussion. But that was poised to be like a Category 3 storm when it hit the coast. So something interesting could happen at the beginning of next week. And I'm not talking about the government shutdown. I'm talking about the regret that all of our infantile politicians will feel when the government is shut down and we have Hurricane Imelda hitting the southeast coast of the United States. It's still part of our country, damn it. So anyway, we can maybe get our problems solved if we start acting like adults or start voting for adults. So that's all I'm going to say about that. There'll be more coming on the satellite in a minute. But I want to remind you, pretty boring week period of weather for us over the continental United States, probably over the last 2 weeks, especially the eastern 2/3 of the country. And we had a 15-day streak of temperatures, high temperatures higher than 75 degrees that ended on Wednesday. So that was 15 straight days, all of them within the month of September. That's not exactly unprecedented, but it is unusual. Embedded within that 15 days, we had 8 straight days that were 80 degrees or higher. The longest such streak is 12, and it was last year. So, I mean, it's just unbelievable how this is happening. And so we're still not done with 80. We may well see it tomorrow, and a couple of days early next week, we might see it again. And who knows if we'll see it beyond then. But last year, we had our last 80 on the 29th of October. So it can go, that's the record. That's the record latest one in Madison. So it can go for a whole extra month. At least it has done that in the recent past. So pretty unbelievable when you think about it. Okay, and then I wanted to show you one other thing related to temperatures, and that's the 850 millibar cold pool that I do starting on September 1. And so I keep track of the northern hemispheres, the aerial extent of -5 degree air at 850 millibars over the whole northern hemisphere. And this is the map that shows the graph from September 1 to the end of December. I'll show you another one in the wintertime from December 1 to the end of February. But here's the time series for this year. Embedded underneath the gray lines are averages of a variety of different types. So the most recent 30-year average, a sort of older 30-year average, and then the overall 78-year or 76-year season, 76 season average in blue. They don't vary very much on this scale of this map. But this is this year's time series. So every single day, except maybe the 1st of September, has been below average compared to the historical record for this aerial extent of -5 air. And in fact, when you add up all those deficits from the climatology, you find out we're the 9th warmest, September 1st through September 25th, in the 78 years. So that puts you at the 89th.5 percentile. You know, when you used to take standardized tests at school, if you came home waving 89th percentile to your parents, they were pretty happy, right? So that's a pretty good grade if you want to win. But we're getting warmer every single year. 89th percentile of the warmest ever in 78 years. I don't think that's very good. My eyes, right around October 1st, I start turning my eye to Western Canada. If it starts to snow there, that gets us set up for the early part of the winter with the potential to stay cold or be cold. There's been nothing like that yet. And so it's early, so I'm not nervous. But if we get it 2 or 3 weeks further along and we haven't seen any snow, even in northern Manitoba, northern Saskatchewan, I'm a little bit concerned that things are off the tracks. This doesn't help alleviate my concerns. So anyway, for what it's worth, that's where we are on the 25th of September. Okay, can we look at the shorter term satellite picture over the continental United States and adjacent waters?
Oh, you want like,
I'll take the infrared if we can get it. If we can get it. Pete's, look at what he's done. He's got all these things ready like that. Of course we can get it. So here it is. Thanks, Pete. So this is the last, I think probably 6 hours probably, right?
Roughly,
yeah, roughly. Over the over continental North America and adjacent waters. So here is Hurricane Umberto. Here is the convective complex over Dominican Republic, Haiti, and southeastern Cuba that's going to turn into, we think, Imelda, and that will be the particular threat for the coastal regions of the southeast United States. Umberto appears to just maybe go a little further northwest and then head out to sea, following roughly the path of Gabrielle, which is now well to the east. And really beautiful storm here on the eastern shore of Hudson Bay, and it developed rapidly. And I intended to show you a whole bunch of different things about that storm, and I'll have to reduce that now because of the scheduling on my Omega calculations. But it's okay, we can still make sense of it. This is a really fairly rapid development, and one of the first winter or cold season type developments of the year over continental North America. So well worth talking about that. There appears to be a secondary one developing here over Alberta province, and so we'll see how they're all kind of connected. And actually, this whole cloud mass that comes along the coast, some of it, I should say, maybe most of this, is tied to a disturbance further to the east. It's not quite as potent as the one that you find further west. And you can't quite see it on this image, but we'll look at the west coast in a minute. A very rapid development in the extreme northeastern part of the Gulf of Alaska that will run into the British Columbia Mountains, and in addition, suffer the loss of an upper divergence valve at the same time. That storm will disappear from the face of the earth after getting down into the mid-970s in a record time. That's an interesting storm as well, and one of the first really potent Pacific storms to make landfall on the west coast of North America this fall as well, because it's been a fairly boring month of September. So things may be changing. One thing that hasn't changed and has ramifications for our day-to-day weather is that the storm track is in central or northern Canada, and it has been there all September long. The consequence is, we'll see when we look at the jet's far north. One can even probably make guesses that there's not really a separation between the subtropical and polar jets far to the north. There's not much subtropical jet activity, at least there wasn't earlier this week. And that keeps the whole continental United States under the threat of feeling tropical. That is 80 degrees Fahrenheit here in Madison in late September. So pretty interesting, even though day to day it's been relatively boring and unchanging. Okay, can we take a look, Pete, at the Oh, I meant to mention Hurricane Nada, also off the coast here of Mexico. It's well offshore, and it kind of goes into the netherworld of hurricanes in the eastern Pacific. They don't often have landfalling threat because of where they end up getting developed, and that appears to be the case with Nada. Okay, what are we going to do? I already mentioned that storm. I think the next thing we probably want to do is take a look at our super peak. Oh, wait a minute, radar. We can look at the radar here.
Or the West Coast.
And the West Coast, too. Let's look at the radar over the continent first. This is also over the last several hours, leading up to about now. So all week long, there's been on and off showers over both the peninsula of Florida and sometimes the Panhandle. Today, it's almost straddling the two. This is a little bit more organized than what we've seen most of the days this week. They've been more popcorn-type cumulus showers, more like what you see over Arizona today. And we'll try and see whether or not this feature here, which is kind of isolated, not particularly well organized, but isolated from the broader daytime heating over the high terrain that led to showers earlier around a broader region this week, if that's tied to some disturbance in the upper level flow. I think that it probably is. And then most of the precipitation or cloudiness we saw on the infrared satellite picture is offshore, and some of it is precipitating, but this is at a really distant range ring, even from Cape Hatteras. So these are probably underselling what's actually falling out of the clouds there, which is commonly the case when they move off the coast. But when you take a look back from the broad perspective, by and large, the 48 states are rain-free. We have a little bit in Florida, we have a little bit in Arizona, and really not much else. A little bit in New York State, but not much else anywhere else. So that's a pretty good day. I contend, people have heard me say this probably like a broken record, the best month of the year here is of September 15th to October 15th, and we're right about in the middle of that. Am I right? Am I right? Perfect, right? And let's take a look at the surface maps too, Pete, because one of the ingredients that's recently come into the right, I guess, orientation for me is we'll click on that, dew point temperature, 56. Get below 60 and stay below 60. I don't know if we're done with 60-degree dew points this year. I don't know the stats on that, but I have a feeling that we have seen excursions at or above 60 later than this calendar day. I wouldn't be surprised if we see it again. But I like it when it's 74 over 56. I mean, I'm not thrilled about the 74 encroaching to 80, but if the dew point's in the mid-50s, okay, we can make a deal. Okay, I feel better about it.
For the rooftop picnic.
What?
Good day for the rooftop.
Perfect day for that event. Perfect day.
Days up there.
And bucking the trend, which of course, as you probably could guess, is that when AMS schedules an event for outside, the weather never cooperates. So this is definitely a counterexample of that. So let's not get lost in anecdotes. It's going to be a nice day. But look at even in St. Louis, 78, 52. I went to school there, and I don't remember dew points below 60 until like mid-October. That's the realm of anecdote. But there were many years where it felt like that. You had to take a shower just walking between classes. Not this year. It's really nice down there, so quite nice. Widespread conditions of that type. Last Friday, I wasn't here. Thank you, Libby, for filling in for me. My wife and I took a tour of the bridges of Madison County. She got kind of hooked on this movie, and we saw the musical. And it was really worth it, I'll tell you. If you ever go down there, just outside of, I guess it's outside of Winterset, Iowa, which is John Wayne's birthplace, if you care. But anyway, it's down in this region, and it was really nice. We had a beautiful day. Low dew points, reasonably high temperatures, good day. Okay, let's go to the super peaks now, because we've got a couple of features of interest to talk about. So I'll start at 500 millibars, Pete, thanks. So here's a 500 millibar map from 12Z this morning. Really nothing over the continental United States. A couple of little, well, first of all, the precipitation over Arizona does seem to have at least some affiliation spatially to a region of cutoff geopotential height and a circulation center over Southern California. So that's different from what we saw yesterday.
About that, ahead of that cutoff that's
Yeah.
in the geopotential, there was a remnant of a tropical cyclone of the moisture from the Pacific that got
Oh, is that right?
trained. So I
Okay.
guess places like Monterey, I was talking to one of our graduates, Dr. Zoe Brooks-Zipton. She was
Yeah.
talking about the fact they got rain in Monterey, which is totally unusual this
Oh,
time of
yeah,
year, and it created a leak in their building.
Oh, how do you like that? So they never even check their roof. They don't have to. It's like old Roman times. They have these roofs with no roof. Just I don't know what to say about that. But that's very interesting. And also southwestern Arizona doesn't usually rain. So there's rain there today. We saw it on the satellites. I mean, the radar, so pretty interesting. Okay, that's a nice little anecdote to add to that. But the main storm track, evident by the strong geopotential height gradient and the waves in that gradient, is higher latitude, mid-Canada. So here's one of those disturbances just off the coast of British Columbia. Pretty intense horizontal temperature contrast at 500 millibars. It's a broad upper trough with a little local shortwave just about to to crash into the British Columbia coast. There's a really intense cyclone underneath this thing. We'll look at that in just a minute. And then here is you can't tell from one map, of course, but this is a rapid development of a deep cutoff cyclone over the eastern shore of Hudson Bay. Temperatures are in the minus 23-ish range. I think the observation here in northern Ontario is minus 22. And so pretty chill, minus 27, sorry, it's colder than that. It's minus 27 at 500 millibars there. So that's a rapid development of a pretty intense, almost winter-like disturbance. And unsurprisingly associated with it is a really strong surface cyclone. So we'll take a look at that in a little more detail as well. One of the artifacts of the development of the cyclone, of course, is the cloud shield and latent heat release. And so this ridging that's built up here in the western part of the Labrador Sea is part and parcel of the development upstream. And that aids the surface development because it makes it easy to evacuate mass out of the column. When you put a ridge and a trough axis closer together, the agiostrophy, the divergence of the agiostrophic wind is much larger for the same size agiostrophic wind.
John?
Yeah.
Another interesting thing is, even though the jet's, we can't really see the jet, I guess, at this level, but the flow at 500 millibars, the westerly flow, is well to the north of the U.S.-Canadian border in general. I think it's a little bit further south than it was last week.
Yes,
So
I agree with
we're
that.
getting so the tail end of fronts, things like that, we'll see in the forecast. We do begin to experience those a little bit more than we did in the last
that's right.
2 weeks.
It'd be really interesting to know, and I don't know this off the top of my head, it's a really good point. What was the climatology in 1975 that would fit this map? I'm going to guess it would have been first week of September or something, instead of the third or fourth week of September, but maybe not. But you're exactly right, and I think you're right, too, that there's a couple of examples where the trailing front associated with this disturbance is going to make its way into the northwest part of our state this time. And that will change things up there more dramatically than here, but we'll have it drying out when that air filters southeast. Okay, let's take a look at 300 millibars. Since we mentioned the jet, it's a little easier to see the jet, although it's not surprising because we just saw the 500 millibar geopotential height gradient is in the same place. What you couldn't perhaps tell is that this is a really roaring jet, the one in the Gulf of Alaska, 164 knots. And the exit region of that jet is exactly coincident with the region where you have the most intense cyclonic curvature. So that's probably why there's such a rapid development in this region, and I'll testify to that rapidity of that development in just a minute. But that's a pretty rapid development that's going on here. All of the dynamical forcings that you need are happening in the same place. There's strong curvature in the flow, and there's strong long flow speed change. You go from 160-ish knots to something like 90 in a short distance. That's a lot of deceleration, so there's a lot of agiostrophic divergence right there. With the cyclone over the Hudson Bay, the jet is lost at the base of the trough a little bit. Remember, the flow is subgeostrophic there, so when the jet was at 120, 125 knots on the northwest side of the prior map, when it grounds the base of the trough, the wind speeds are actually lower there, and so the jet seems to disappear. But part of that is just a testimony to how strong the agiostrophic countervailing flow is at the base of the sharp trough. And then this feature south of Greenland is more or less a straight jet downstream of the ridginess, which is partly a function of diabatic heat driven by this cyclone. Okay, so that's kind of interesting. Let's take a look at 850 before we go to a couple of other diagnostic pieces, and then we'll be done. So at 850 at this time, you can see how intense the disturbance is in the eastern Gulf of Alaska. That's the 1,200 meter line, so these are every 30. That's, I think it's trying to tell us like 1,159 or something like that in the middle of this. That's a really low geopotential height at 850. So that's an intense cyclone. And again, one map by itself doesn't testify to the rapidity by which it got to that intensity, but we'll see that in just a minute. Interestingly, here's like a lee-side pressure trough in the immediate lee of the Canadian northern U.S. Rockies. And the reason why I have that sense that it's a lee-side trough is that the geopotential height minimum at 850 is coincident with the theta maximum. And so what's happening is flows over the high terrain, warms the air up maximally where it's sinking the most, and that same sinking is stretching the column and generating the vorticity that's manifest in the troughiness. So whenever you see that, that's a pretty good signal of a strong lee side pressure trough. And sometimes the somewhat unusual thermal structure that develops in response to these processes has ramifications for the way weather systems take shape to the east. And one particular example of that that's pretty obvious is that there's strong warm advection in the immediate downstream side of the thermal ridge in the lee side trough. So over southern Manitoba, southern Saskatchewan, pretty nice warm air advection at 850 is going to make for an unusually warm day in the southern prairie provinces. And yet, there's no differential temperature advection to speak of, so it'll stay cloud-free. So you're just getting an importation of warmer air for free, meaning you're not going to get obscured skies, you're not going to get a precipitation threat. And that's very often the case with these lee side trough beaches. And in the wintertime, for us, this whole thing will set up a little further south. We end up in the warm advection region with continuous passage of disturbances at higher latitude. We tend to have situations where there is some differential temperature advection in the warm air advection region down shear of the downstream of the lee side trough axis. Constant snow flurries are the result of that here. So we get a lot of days on which it snows. Many of them are days where it's a lee side trough passing either to our north or to our west, and we're in the warm advection region, we get a little bit of snow. And then the other interesting storm is the intense disturbance. This is down below 1,011. I mean, below 1,100 geopotential height meters. I think that says 1,090 right here. So somebody's fishing trip in Ontario has been ruined. If it were me, it'd be highlighted. So it'd be better. I'd be more thrilled. -2, so it's snowing to the north here in this part of Hudson Bay in Ontario. And then look at the thermal structure. Really nice thermal ridge wraps right up to the back of that. It's deeply occluded cyclone. So a really nice wintertime storm. And if I had my pencil and paper, I'd draw that nicer than it's done by the computer. But I have real intelligence, not artificial intelligence. Okay, let's, did you see how I did that? Let's,
Well done.
thank you. Let's go to Alicia Bentley's maps if we could. And the first thing we'll do is take a look at, I think that was it, Pete. Yeah, right here. And this is the Pacific. Let's back up a couple of times. I think you can do that with just the, well, no. Let's go back to that Pacific map. And then use and then use the arrows to click back and forward in time. Yeah, okay, so right there's perfect. So here is Typhoon Nuragai. I think I got the name right, but I didn't look it up again, even though I told Michael I would. It's one of those names. This was a pretty intense typhoon. I think at one point it was a Category 4 storm. Not at this point in its history, but at one point it was. I don't believe it had any substantial landfall. Never made it to the Philippines. Clearly didn't make it to Japan. But look at what happens. That's purely a tropical system. And then there's this wave train, a somewhat muted wave train at mid-latitudes. And muted I mean by, look at the undulations here, troughiness in the thickness field, a little bit of ridginess and so on, are not really high profile. And the jet doesn't seem to have really strong undulations in it either, although an intense jet that's slightly anticyclonically curved is downstream of Nuragai, partly perhaps energized by outflow from the tropical cyclone. Right in this region right here, there's a really intense thickness contrast. You can see right there, and a little bit of a sea level pressure depression. If we go to the precipitation on this map, you'll see, where is that? Right here.
Last one.
And then these are now 850 millibar isotherms in red and blue when they get to 0 or colder. So a region of pretty intense horizontal temperature contrast. One imagines, given the flow that might be associated with the low-level isobars, that it's strongly confluent or frontogenetic along this. And that's kind of nicely backed up because the air is rising on the warm side, producing this band of precipitation. So that's mostly a linear band of precipitation, not particularly potent for cyclogenesis. And it's going to last that way for several time periods. So let's click forward a little bit here, Pete. So look at that. Still sort of an elongated minimum in sea level pressure trying to develop. Most of this precipitation is also linear, I think in response to frontogenesis along that baroclinic zone. Let's keep going. Same thing, hardly a development. What development there is, it's a little bit down shear of the length of the baroclinic zone. Keep going. Starts to change a little bit, but the linear nature of the precipitation band does not change. And one more time, then we start to see, hey, why is the precipitation focused only here? It's no longer really focused along the baroclinic zone. It seems as if the dynamics have changed because the precipitation forecast, which I think probably likely verified, has totally changed its geometry. In response, I would suggest, to some change in the dynamics. So let's take a look, if we can, I'll keep my finger here. Let's take a look at the 500 millibar vorticity. And here's the strip of vorticity along the upper baroclinic zone. These isotherms now are 500 millibar isotherms. But right where the cyclone starts to develop is this little bifurcation from a linear structure to something that's a little bit more on its own. And let's go one more time ahead. And look at that. And the blue is, I think, 500 millibar ascent. So it's ugly and kind of gets in the way. But this is approximately, yeah, this is this morning's map. So this is when you have that really sharp curvature maxima, strong horizontal temperature contrast, so the strong thermal wind, very strong PVA by the thermal wind. That's what's driving the ascent at this time. Let's go back to the surface map, because we stepped ahead of time from the last one, or the precip map. Kind of a little bullseye of forecasted precipitation. So that's where the intense vertical motion is. And it's gone from being mostly frontogenetically produced in the early stages of this development to a strong response to the upper vortex. A reasonable question is, how come the upper vortex changes its geometry and its orientation? I don't have an answer for that. That takes more time to think about that. But this turns into a really deep cyclone. This is the 1,000 millibar isobar, so that's 96, 284, 980, 976, one more time ahead, Pete. Even worse than that. So this is 992, 840, 62, 68, 64. It's below 964. Then what happens the next time? Or one more time after that. Where is it? So it runs into Vancouver Island, which is usually a nice place to visit, but not if you're a 968 cyclone with very little upper level support. This is the wrong place to go if you want to be sustained. And if you keep going at one more or two times, it's completely disappeared from the map. So in record time. Okay. Let's go to the 500 millibar flow one more time. Look at this. There's absolutely no curvature in the flow anymore. There's no flow, it's weaker. Everything at upper levels has completely dissolved. And that's what was fueling the divergence that develops the cyclone underneath it. And as soon as the divergence pump disappears, you can't maintain the cyclone. Because you drop the pressure to 968 at the ground, there's a lot of cross isobar flow. That mass converges, it would by itself, it would raise the pressure. If you can't get the mass out the top, that's what's going to happen. The pressure's going to rise at the surface, and that's exactly what did happen in this case. Even though there's a potent wave well to the west, there is nothing in the vicinity of that cyclone. Really interesting. Okay, and then one last thing. Let's go to the Hudson Bay storm on the same map. So we'll go to the continental United States, or whatever it's called, North America. And let's go back to, let's keep going back. Yeah, right there's a good time to start, I guess, Pete. We could even go back one more time. So, a very modest little wave in the flow at 500 millibars. The thermal wave axis, so the trough axis is right here in the geopotential, but the thermal wave is displaced a little bit to the west. In developing systems, they are out of phase. And in this way, that the thermal wave trails the geopotential height wave by maybe a quarter or so of wavelength. And you see at the initial time here, this is the ascent. We can go to 850 in a minute. That's the ascent. It's linear. There's no particular balled up region of it. Let's take a look at the 850 map that we've seen before on the other one. Not that, the precip map, the one at the bottom. Yeah, thanks. There's an elongated region of slightly lower pressure. That's 1,008, so this is 1,004. That does not look like a very impressive initial condition, but there's a precipitation band quite like the one that was in the Pacific that's probably responding to frontogenetic forcing in that region to the west of Hudson Bay. Let's click ahead of time. Maybe one more. Goes from maybe one back now. Still pretty linear. One more ahead. Starting to look like it's a little concentrated. One more ahead. Very much more concentrated. So something, again, changes in the nature of the forcing that leads to the precipitation production. Here we have strong 850 millibar contrast in temperature, strong thermal wind. I'll bet you 10 to 1 the vorticity's got a maximum right about here at 500 millibars. Wow, how do you like that? There it is. Now, I saw it ahead of time, but I would have guessed that anyway, even if I hadn't. I really would have. Strong 500 millibar temperature contrast. One more click ahead. The vorticity values here are on the order of 3.5 times F. The baroclinic zone goes right through it, so the PVA is right here, really strong. Let's see what the cyclone looks like. I bet that's the center of it. Yeah, pretty close. And that's right where the precipitation's being strongly generated. So this thing gets down, as I showed before, I think, down into the low 970s on the eastern shore of Hudson Bay. And it undergoes a different kind of, a similar transformation, but a little bit different in the sense that there was a better upper level wave to begin with in association with this development. But I think it also started out as a frontogenetic vertical motion producer and then turned into a PVA by the thermal wind vertical motion producer. And that concentrates the vertical motions in a smaller area, in a circular, somewhat circular area, and that drives incredible development. And you can see that in the omega fields from the QG omega, because you can attribute them to different scalar variables where they come from. That's gone, unfortunately, on my website. I had it ready for the discussion, but I can tell you that if you split the total PVA by the thermal wind, which overestimates the vertical motion, if you split it into curvature vorticity advection versus shear vorticity advection, for this storm, overwhelmingly curvature vorticity advection is driving the development. For the Pacific storm, nearly equal contributions. So that suggests to me there's something different about those developments that might be worth trying to stratify in a collection of thousands of cyclones. And I've been working on this problem in my head, and I have some pieces in place that I might be able to work on it outside on a desk top with a machine and start thinking about whether or not there's something to that. So anyway, that's a problem I want to continue to pursue.
So the change in the structure of the cyclone and the precipitation, probably, and also the upper wave, probably is at least in part associated with a change in, or the diabatic heating that's being released by the precipitation.
Probably,
So
yes.
curious, we could look, Pete, at the dynamical tropopause for this one. For this case, go back a few clicks and, yeah, there's a DT. And go back.
Yeah, so this is about where we started, or close to it. There's the 850 milliwatt, 920 to 850 cyclonic relative vorticity.
Vorticity, right.
Yeah.
So as we step forward in that, do we see?
It's still linear.
Evidence of,
Still linear.
yeah. It's like that plume
Here comes this wave.
of warmth actually shoots out well ahead of it.
Yeah.
So it's not even near the,
This thing comes in and narrows and focuses
right.
upstream of the development. Look at that. That's a nice connection between this upper wave and the beginnings of, some more interesting geometry to the vertical
Could you go
motion
back
of
2 clicks,
vorticity.
Pete, and then go forward again? Okay. So still not really showing. And then forward, a few more steps.
Yeah, right there. Look at that. That's a balled up vortex.
Yeah. But it doesn't really seem, I'm surprised that the dynamical tropopause doesn't really show too much warming. I guess to the northwest of that, you can see that sort of curved.
Right in here?
No,
Oh, right here.
Yeah, right there. That little
That's the upper
notch
wave.
that's getting eaten out. The
Yeah.
higher values of potential temperature to the northwest of the blob of vorticity.
Yeah, right, yeah.
In there, yeah, that's where the warming, I guess, is occurring with
Yeah.
the latent heat release. But it's late. So
It
may
is
not be
kind of late,
fully
yeah.
a-
And this is far north.
Yeah.
Any storm in Canada struggles with mixing regime. They're just too far away from all of the moisture sources. You can't almost get farther than, except for the Hudson Bay underlying it itself, you can't get much farther from the main moisture sources than central Canada.
So that may put a brake on how high of potential temperature perturbation you see at the dynamical tropopause, because you
Yeah,
can't
I guess so.
get the theta E or theta
Yeah, I guess that's
that
right.
high just downstream.
I guess that's right. That's right. And what are the ramifications for that downstream over the Labrador Sea? If you've got a collection of these and they can't make it warmer at the tropopause over the Labrador Sea, then you don't have weak stability, you don't have development there, and all kinds of other things might be the downstream consequences of that. Yeah, contrast that, this warm air on the tropopause with this associated with the thing that we think originated in the tropics. It's just dragging the tropics with it effectively to the coast of British Columbia. So,
John, I was
Yeah.
going to say that in Alicia's map, you can look at the irrotational wind, which is directly related to the diabatic process.
oh, yeah.
That starburst right downstream of this, you can kind of see is it the TPV moving the show, or is it this diabatic component?
Oh, yeah,
So let's look at
So
that.
I think, yeah, in
The variable
yeah, there should be like a,
irrotation.
Irrotational wind.
Yeah, right there, second one down.
That one, yeah.
yeah, there's not really that much diverging.
That's right.
Rotational.
That's a really good point. And the little bit that there is not really hitting a strong gradient of PV, so it's not really changing, much of the structure there. Whereas this one over here, well, it has the same characteristic. Very little of that outflow is kind of channeled back across the strong PV gradient. The gradient in the background is stronger, so that I guess PV frontogenesis is stronger with that storm to the west, but not because it has a stronger and more directed flow. It's just because it has a better, stronger gradient behind it. Yeah, that's really interesting. That's a good way to look at this. Very cool. Well, that's all I have. So thanks for the conversation. Any other questions or comments? Okay. Mike?
Just heads
Oh.
up, because we may be able to get sort of a 1 o'clock deadline, because the meeting here at 1, so I didn't realize that until I got here.
Okay, if we go to NHC first, please. I don't think I brought that up yet. Okay, so we're going to just very briefly talk about Umberto, just currently, actually, we may have an update. No 2 p.m. update. 90 mile per hour winds, pressure's down to 979. Umberto's undergoing a rapid intensification as we speak. It was at 75 mile per hour winds earlier this morning. It's now down to up to 90. And so this is going to become a pretty ferocious storm. If we were to just go down a bit to the, for Umberto, the experimental cone right here, and we can see sort of the forecasted track becoming a major hurricane by tomorrow morning, and then remaining a major hurricane as it goes just to the southwest and west of Bermuda, and then begins to recurve into the westerlies. So a fairly significant cyclone. You don't see those that often in the Atlantic, and it's much more dramatic than anything that John was just talking about. But okay,
That's for sure.
there's but that's a pretty decent storm. Next, the area that's of interest, the Hurricane Center, is, they call this INVEST. And actually this is relatively up to date. But they now have a 90% chance of it becoming a named tropical cyclone. But it's still fairly disorganized. And I think one of the things is its proximity to the western Cuban coast, and we'll look at that from the SIMS page in just a moment. It's not, but the expectation is for it to develop. Then the question is, really, John was talking about the possible landfall that we've seen in some of the model solutions along the southeast coast of the United States. It's not 100% clear that's going to happen. And we'll see that in some of the forecasts. So let's quickly go to tropic.sims. I think I already have it up there. Yes, it's the C page. In fact, behind this, I think that's already brought up. And if we click on, this is where the storm is currently located. Maybe we can refresh this, or just exit out, I guess, so we can come back. Sims right here. And then click on the eye. Not the eye of the storm, it doesn't have an eye yet, it's just a... No, that wasn't planned, John, it just happened. It just happened. We'll go to visible. Show you some visible imagery, and then we can go to anim GIF to see the animation of this. And what's really interesting, and you can actually see it on the superpeat maps as well, there's an area of lots of warmth here in the northern Caribbean, northern central Caribbean, and just southeast of the Bahamas. This is all from the outflow from the tropical convection, the deep convection that's occurring there. But again, it doesn't look very well organized. It is a cluster of thunderstorms that's concentrated. I guess the minimum sea level pressure is located roughly here. We'll see that when we look at a couple maps in just a moment. But I think the question is, how rapidly will this develop? And I think any significant development is probably going to have to wait until it gets a little bit further north of the north coast of Cuba. One thing I'd like to look at, where is it? Oh, come on. It is the MPI. It was on there. I guess it's not just going to show up. There's an option to show sort of the maximum potential intensity of these tropical cyclones, but it's normally here. I just saw it this morning. Clicked on it. But if you look at, there's this quantity called MPI, maximum potential intensity for tropical cyclones. And it's a function of sea surface temperatures, sort of tropopause level temperatures, relative humidity over the depth of the column. And it's using sort of fundamental thermodynamics and dynamics of, a vortex and gradient wind balance. You can come up with estimates for the maximum winds, as well as the minimum sea level pressure that could be attained if there were a very efficient Carnot cycle type engine in the atmosphere. And some of the sea level pressures of the maximum intensities for a cyclone in this location based on sea surface temperature, outflow temperature, forecast relative humidity, or current relative humidities, is down into the low 900s. And so that's something that's, again, maximum winds, if you were to believe it, in excess of 200 miles per hour. So the potential for rapid development if the upper level conditions are favorable is intense for this particular storm. But the question is how quickly will it organize itself as it moves northward. So let's quickly go to here, tropical tidbits, the little hurricane symbol. And we're going to scroll down to we have current storms. Okay, this is for the forecast from Berto. Scroll up just a little bit, please. Current storms, a little bit more in the left, different storm. And we'll look at Invest 94L, which is the one that we've been looking at. Again, a mess of convection in the IR imagery. If we scroll up a little bit, click on this map, you can just sort of see whatever observations are around. This is Kingston, Jamaica, the airport there. Manly International Airport has a wind out of the south with a minimum sea level pressure here. That doesn't look very impressive. This is still disorganized. Southeast Bahamas, we have a easterly wind right there. There was a bit earlier of a trough axis. You can actually see there's a wind shift here, so maybe the vortex is moved just a little bit to the northwest of this position, but not very well organized. Let's click out of that, go back to the other map. Just go back or close that out. And then possible tracks for this. This is based on models initialized at 12:08 this morning. Some of them many of them still have a landfall over, in the Charleston and southeast coast of North Carolina. Savannah is our forecast city, so that might make things interesting for those in the forecasting contest. But again, broadly moving northward, and then the question is will it recurve? And we'll see some of the forecast solutions from, not all the models are shown here, have it actually sort of hooking off to the east just before a landfall. Okay, let's go back out of that. And we will go to, we did Sims, no, not that one just yet. Actually, let's go to bring up Pivotal, I didn't bring that up. And look at a quick animation, surface sea level pressure. As Pete's bringing that up, since his time is short, the weekend forecast is going to be dominated largely by the passage, GFS please, of that lee side trough that's developed here and a tended front that's going to develop briefly once it passes by. But let's animate this, go from single image to animation please. Kind of rushing through this, I didn't realize we had a 1 o'clock deadline for today. And let's animate that please. And scroll up a bit, we'll first look at the emergence of this system. So here's what is expected to become Imelda. It does make landfall in the GFS forecast near Charleston and produces heavy rain. So the impact you might expect here are going to be significant rain. Rainfall totals, if we look at the total accumulated precipitation post-landfall, are close to 20 inches here. And so a couple things to watch. Remember, John was showing an area of showers and thunderstorms that was over Florida and Georgia this morning. Let's animate that.
Wow.
Right, so you can see that. And if you bring the cursor down, well, you can't do it on this. I actually can with animation. Right there. So we're looking at, oh, that's for sounding. You have to look at an individual map, Pete. But the thing is, potential for some significant precipitation there. And any precipitation that occurs before this landfalling cyclone does is only going to exacerbate the issues here. So the things that people would watch for if this forecast were to verify, in addition to the wind and coastal flooding associated with this, river flooding from the fresh water, the rains from the tropical cyclone itself, and that can sort of screw up the flow of the river. As the river's trying to flow out to sea, get lots of rain here, but you get winds pushing the water back inland. That can lead to some significant flooding, not from the rainfall explicitly, but from sort of the merger of those two features of water. You can see the tracks of the two tropical cyclones. Go back to the surface map for a moment, Pete, please, and let's switch the models, go to the icon model as an example. Something a little different, and then animate that.
941. Wow.
Maybe a different beast. Okay, and we animate that.
Oh,
Look at that.
oh.
So we get this interaction of these two vortices, this binary interaction that moves off. We can go back to the beginning and just see that one more time. So it's not a clear-cut case that this is going to be a landfall. And it's going to take until, probably middle of next week before we actually see something happening. So I think the timing for being sometime in late Sunday is probably a little bit way too early for that.
That was yesterday, but not now.
Yeah, so we can see that. And if we go to the GDPFS, that's the Canadian model, GDPS. And then just animate that. Bring it up. You can see quickly
Oh, yeah.
as it nears landfall, it then moves out. And we might have the European. Oh, and it comes back. Let's actually just let it animate.
It's like, I'm gonna try to hit Savannah. Oh, no, I'm
I have enough
gonna
forecasting.
go for North Carolina.
So as this ridge begins to build back in, bang, you gotta. So that's a solution I didn't see before I came down. And the European Center model, we select that one, UW-AOS. It's out probably far enough to see what might happen with this. Yeah, that's far enough out, and we can just let it go. Just to the coast, holds there, then finally moves inland. So prolonged rainfall. So I'm thinking there was it Helene
Yeah.
several years ago that produced this slow-moving tropical cyclone and just dumped heavy rain in parts of the Carolinas day after day.
In the North Carolina mountains.
Right,
It's still
and not Helene, sorry, not Helene. Helene was last year. I'm thinking of a cyclone that formed out over the Atlantic and then just brought in a huge amount of rain. Just, what's that, Florence? Yeah, okay, that was it. That was several years ago, and that's, when we see seeing that done again.
Feels like Helene.
Couple other things in the forecast as we're just animating this. You can see that lee side trough makes a passage over. So we go back to the beginning. We can see this high builds in, things begin to cool off by the time we get to Monday, and then a big ridge begins to form over parts of the continental United States. Last thing I want to show, because I know time is short. We'll go to the 5 for just the wharf for just a second. Do two things. Scroll down to the bottom. We won't do the meteorogram, we'll just go to the time height. Sorry, John. And what we see here is, I was mentioning that we're getting the westerlies, we're just a little bit further to the south. It's one of the rare times since the semester has begun that we actually see dynamical tropopause briefly peak in here. You can see the cold dome beneath it, not the most impressive thing. But we also see, if we scroll down to the bottom, an interesting change in winds. We have these westerly winds, things are warming up, well mixed layer forms tomorrow afternoon. And then sometime tomorrow evening, wind shift from west to northwest. You see the relative humidity shooting up, vertical motions also briefly as that lee trough passes by, the axis of it passes by. Things begin to cool off. You can see these isotropic surfaces just popping out of the ground as temperatures begin to cool off a little bit. So last thing is, if we go, I think it's here. Nope, not here. Here. Nope. Last one. Where'd it go? Dang it. Let's try this. Yeah. Okay, so this is another sort of meteorogram. This is from the Schreff Short Range Ensemble Forecast System. And what this shows is a collection of all sorts of short-range models being displayed here. With this variable that we're looking at here is the 3-hourly temperature for the next 72 hours or so. And you can see, first of all, tomorrow being relatively warm. You can see the spread in the forecast. There's a lot of confidence in the forecast, and the spread begins to increase as we get into Sunday. But look, we're actually going to get cooler, which is nice. I think with that frontal passage that we talked about happening tomorrow afternoon, or tomorrow evening. And then on Monday, we begin to warm up a little bit. But a lot of spread here, but possibility, and there's some models that actually get us into the low 40s, actually over the weekend. If we go back a click on this page, again, I don't know if people are waiting outside. What time were they going to be here, people?
It was scheduled for 1 o'clock. If there's nobody out there, I wouldn't worry about it. And maybe they're at a different room.
Please knock if you need to come in. Let's go to the global ensemble, so the GFS. And we have to click down to get Madison. Maybe we can slow down a little bit to show a couple other things. That's not quite Madison. Oh yeah, it is. Dang, all right, there we go. So let's pick, instead of QPF, well here's QPF. Looks like a pretty dry week coming up. Okay, this is using the ensemble forecast products. Nothing precip-wise expected for us. Interestingly enough, in the Schreff, there was a little bit of precip with the frontal passage, or the trough passage tomorrow. It kind of becomes a cold frontal passage, but that was not much precip in it. Let's change to temperatures. Look at the temperatures for the week ahead. And again, you can see even in the short range forecast, GFS is not getting us down to the 40s, certainly until maybe this is going to be tonight, tomorrow night. This is Sunday night into Monday, maybe cool and then begin to warm up. But the average of these forecasts in the black line right here suggests that we're going to be, this is a cooling trend by the end of the week, which is going to be kind of interesting. But cool, what does that mean? And this is still highs, possibly somewhere around 70 or so. So with possibilities of being as high as temperatures getting to the 80s or as low as mid-50s, but that seems kind of somewhat unlikely. So decent spread. If we go to our forecast city or near our forecast city, which is what, Savannah? Is it Stanford?
Yeah.
Right.
Ooh, downward trend.
See a downward trend probably because of precipitation in the forecast, and we can look at the precip there. If we go back to QPF. Again, I'm glad I'm not forecasting. But this is a tool that's available, online that you can go to, and particularly for the forecasting contest, as you get to that, obviously a shorter range, you can probably use the Shref to at least begin to sort of pick out some things that might be of interest to you. And certainly I'm willing, if anyone has questions about things to look at, I'll be happy to entertain those questions during the contest. But, possibility of a really wet period sometime next week, and that's going to be the 29th, which is what, Monday? Yeah. Oh, they're here? Okay. All right, but anyway, weekend looks dry, cooler on Sunday with a strong passage tomorrow evening. Have a wonderful weekend. Thank you, John. Thank you, Pete.